So this is one of the problem from assignment model. Assignment model problems are solved by using Hungarian method. Now in this Hungarian method, the basic steps are just to check whether it is balanced or unbalanced, then is it going to be maximization or minimization, and then solving it by using Hungarian method. Okay, so Hungarian method steps are row minimization, column minimization, and then making the assignment. And if assignments are not possible there, then we will have to go for the drawing of the lines. Okay, so based on this, as in how we are going to solve this problem by using this Hungarian method. Okay, now let's check it out. What is the problem? So the problem is given like this: the following table gives estimates of the profit in rupees each worker would earn for a respective task. Okay, so there are 4 different tasks: task A, task B, task C, and task D. How should the task be allocated one to each worker so as to maximize the total earnings? Okay, so as to maximize the total earnings. Okay, so these figures are nothing but the earnings by that particular worker. So there are 4 workers, first, second, third, and fourth, who are going to get the 4 different tasks. Okay, that means one worker, one task. Okay, this is going to be the always policy in any of the assignment problem, that one job goes to one worker. Okay, like means 1 to 1 is going to be the assignment, 1 to 1 is the assignment. Okay, so 4 workers and there are 4 different tasks. Okay, so as it is, number of rows are 4, number of columns are 4, that means the given problem is balanced problem. Okay, so the first query will be solved, that it is a balanced problem, and if it is not balanced, then we will have to add either a dummy row or dummy column. Okay, depending upon the inadequacy, right? So first thing is clear that it is a balanced problem, so no need to worry about that. The second thing that we have to know is it a maximization problem or is it a minimization problem? Okay, so it is clearly mentioned here. Okay, and as in how, if it is not mentioned, looking to the wording also we can easily understand that. Okay, so see, the problem is basically regarding the profit in rupees. Okay, so if the profit is there, it means obviously profit is always to be maximized. If it is an investment, if it is a cost, then it is going to be a minimization. Okay, if it is a efficiency, it will be a maximization. If it is a profit, it will be a maximization. Okay, and here it is clearly mentioned that the objective function of the problem is to maximize the total earnings. Okay, and these values are nothing but the earnings. Okay, so this 5 rupees means the earnings by worker 1 if he will get a task A. If he will get a task B, earnings will be 40. If he will get a C, earnings will be 20, likewise. Okay, so earnings for 4 workers for 4 different tasks has been given. We'll have to solve the problem by using Hungarian method. Okay, so assignment models are solved by Hungarian method. We'll have to solve the problem by Hungarian method to maximize the total earnings. Okay, to maximize the total earning. Okay, so let's see how to solve this particular problem by using Hungarian method. Okay, so this is the problem given: 4 tasks, 4 workers. Okay, so these 1 2 3 4 are nothing but workers. Okay, and these ABCD are nothing but 4 different types of task. Okay, so 4 different types of task has given. Okay, so that we'll have to now solve by using Hungarian method. Okay, so we know that the problem is given of maximization. The problem is of maximization. So to solve it by using Hungarian method, we'll have to convert this problem into, first of all, minimization. Okay, so first thing is to convert problem into minimization. Okay, so this conversion is required. Okay, how to convert that particular problem? We know that what is the step to convert this problem, that select a highest element or the maximum or the largest element from the given cost matrix. This is our cost matrix. This is our cost matrix. Okay, so this is the cost matrix given, and this cost matrix we have to solve by using Hungarian method. Okay, so first of all we will have to convert maximization into minimization. Okay, to convert that, there is a basic process that select largest element from the given and subtract entire matrix from that largest element. Okay, we'll have to subtract entire matrix from that largest element. Okay, no, so now here this 40 is the largest element, we'll have to subtract all the elements from the 40. Okay, so let's take it now. 40 minus 5 will be 35, 40 minus 40 will be 0, 40 minus 20 come out as 20, here it will be 35, then 40 minus 25 is going to be 15, here 5, 40 minus 30 will be 10, minus 25 will be 15, third 40 minus 15 will be 25, minus 25 will be 15, minus 20 will be 20, minus 10 will be 30, minus 15 will be 25, minus 5 will be 35, minus 30 will be 10, and 40 minus 15 will be 25. Okay, so now this is how going to be the numbers. What we have done, selected a largest number and subtracted all the numbers from it. Okay, so this was the first step that we have considered. Now the second step is row subtraction. Okay, so the second step is coming as a row minimization or row subtraction, rather we'll write as a row minimization. We'll write this as row minimization. Okay, so next step is row minimization. Now in this step we'll select a smallest element from the row and subtract it from the entire row. Okay, so the smallest element in the first row is 0. Okay, when we will subtract it from the entire row, though it is going to be same. Okay, so 35 minus 0 will be 35, 0 minus 0 will be 0, 20 minus 0 will be 20, and 35 minus 0 will be 35. Okay, so it remains as it is. Next, in the second row, the smallest is 5, so 15 minus 5 will be 10, 5 minus 5 will be 0, 10 minus 5 will be 5, and 15 minus 5 will be 10. Okay, in the third row, the smallest element is 15. Okay, so 25 minus 15 will be 10, 15 minus 15 will be 0, 20 minus 15 will be 5, and 30 minus 15 will be 15. Okay, in the fourth row, smallest element is 10, so 25 minus 10 will be 15, 35 minus 10 will be 25. Okay, then 10 minus 10 is 0, and 25 minus 10 will be 15. Okay, so this is the row minimization. So next step is column minimization. Okay, so next step is column minimization. Okay, so next step is column minimization. In this column minimization, we will select smallest element from the column and we will subtract it from that particular column. Okay, now in the first column, the smallest element is 10. Okay, this 10 or this 10, we can have any one, and the values will be 35 minus 10 will be 25, 10 minus 10 will be 0, 10 minus 10 will be 0, and 15 minus 10 is going to be 5. Okay, in the second row, 0 is the smallest. So that means row column will in second column 0 is the smallest. So if we will subtract 0 from any of the element, it is going to be same. So 0 0 0 and this 25 will also remain same as it is. So in the third row smallest is again 0. Okay, so it will again remain 25 minus 0, 20 minus 0 will be 20, 5 minus 0 will be 5, 5 minus 0 will be 5 and 0 minus 0 will be 0. In the fourth column smallest element is 10. So 35 minus 10 will be 25, 10 minus 10 is 0, 35 minus 10 is 15 minus 10 is 5 and 15 minus 10 is 5. Okay, so these are going to be number like this. Okay, so now this is 5. Now we'll have to try for the assignment. Let's try for the assignment. Now in the first row there is only one 0, so I will make assignment here and cross the remaining 0 in that row. Is there any 0 extra? No. In that column, yes. So I will cross this 0, I will cross this 0. Okay, so go for the second row. How many zeros are there? 2 zeros. So we'll take it later on. Okay, in the third row how many zeros are there? There is only one 0, so I will select this 0 and immediately I will scratch out any extra 0. So this is extra, scratch this. In the fourth column, in the fourth row there is one 0, make the assignment there. Is there any extra? No. But now come to the second row, we have only one option, we can make assignment here. Okay, so what is the order of matrix? How many number of rows are there? 4. 1 2 3 4. Or how many number of columns? Only 4. That means we require 4 assignments. And how many assignments are there? First one, second one, third and fourth. Okay, so it is the optimum answer. Okay, now let's make it. So first, this is all these are workers and these are tasks. Okay, so if we will make here like this, answer, final answer will be worker, task and profit and profit and profit. Okay, so worker number first, which task he has got? Finally, which task he has assigned? B, task B. Okay, and what is the profit for first task? If you will assign to B, here is the 40, so this 40 will have to take here. Okay, then second worker, second. Okay, for the second worker, which task we have assigned? D task, task D. Wherever we have made the blocks, that is the assignment. So D block means here we have made the assignment, so it is 25. Third worker, here we have made assignment, so it is A, it is a. Okay, and here we have made the assignments, so it is 15. And fourth is C, we have given him C task, so it will be C task and it is profit is 30. Okay, if we will calculate total profit, it will be 40 plus 25 will be 65, 570 and 80 and 3 110. Okay, so it is 110. Okay, so we can make it rupees 110. So this is going to be the final answer. Okay.